Welcome back to my YouTube channel again. This is Satyaraj, Assistant Professor working in RMK So I'm going to continue with the Hyperlan 2 in today's lecture. So first we are going to see the Hyperlan 2, why we are using this Hyperlan 2, since it provides an access for the futures of broadband radio net access network, BRAN network, as well as wireless ATM. So these are the futures of Hyperlan 2. So the Hyperlan 2 operates with a operating frequency of 5.15 to 5.35 gigahertz frequency, and data rate up to 54 Mbps. So first is nothing but high throughput transmission. So the high throughput transmission, in sense we are using the technique of modulation called orthogonal frequency division multiplexing, OFDM. So this is done in the physical layer. So with respect to this, we can also provide the dynamic TDMA, time division multiplexing, then time division duplexing based MAC protocol. So using dynamic time division multiplex accessing and time division duplexing based MAC protocol, so we can establish high throughput. So in physical layer and network layer, we have a data rates of 54 Mbps in physical layer, and we can establish 35 Mbps in network layer. So we can also send a high throughput transmission we can achieve by sending a MAC frame of constant length of 2 milliseconds. So next is connection oriented system. So the connection in sense we are going to establish connection between sender and receiver. Sender is the mobile, and with respect to different access points, that will be the receiver. So all connections are time division multiplex. All connections are time division multiplexed over radio frequency, that is R. So it can also use two connections. One is point to point connection, and another one is point to multi-point connection. So the point to point connection, this can be established with respect to unidirectional, and point to multi-point can be established with respect to bidirectional. So QoS stands for quality of service support. So after once a connection is established, so the QoS setup is very simpler. Since the connection establishment has one set of QoS support, so it has good quality of service parameters. So hence the performance will be good in Hyperlan 2. So next is dynamic frequency selection. So dynamic frequency selection, in sense it has a built-in support. It has a built-in supports which selects the appropriate frequency in the coverage area. So appropriate frequency. So whatever appropriate frequency available in the coverage area, that will be taken, and the frequency is chosen with dynamically. So example, we can have a current interface level, that is current interference level with the usage of radio channels. Current interference level with the usage of radio channels. That is the example of dynamic frequency selection. Next is security support. Coming back to the security, that is by means of authentication and encryption. Already we have seen the security side, authentication by means of mobile terminal and access point. So with respect to mobile terminal and access point, we can achieve the authentication, and encryption by means of a standard called advanced encryption standard, data encryption standard. So we have AES, DES and triple DES, triple data encryption standard. So hence to overcome the attack called man in the middle attack. So man in the middle attack. So this is an attack which can take the data from the system. So this results in eavesdropping. So packets will be dropped. So for providing security support, we need authentication and encryption. So we are overcoming the man in the middle attack by means of using advanced encryption standards, AES, DES or triple DES. Then mobility support. Mobility support is done during the handover process. So during the handover process, all connections will be taken care with including the QoS parameters which supports after the handover. So next is application and network independence. So access point will be connected with respect to LAN in case of Ethernet, that is in case of what, wired communication. But in wireless communication we have IEEE 1394 standard. So according to this, it supports with respect to Firewire. So Firewire support which is supported the audio and video devices. So this is an important future of Hyperlan 2. Then comes the power save mode. Power save mode is that the Hyperlan 2 devices will be in sleep mode and wake up mode. So what is sleep mode? So sleep mode will save the power. So how the sleep mode will save power? In sense it will have the shorter latency. Latency in sense you have less delay. And in case of wake up mode, so wake up mode means it consumes low power. So next is a comparison between Hyperlan 1 and Hyperlan 2, very important. So the application we use in Hyperlan 1 is wireless LAN, and the application we use to access is with respect to WATM, that is fixed ATM networks. So frequency is 5.1 to 5.3. Center frequency we have 5.2 gigahertz for Hyperlan 2. You can also start working Hyperlan 2 with respect to 5.3 also. So the topology is decentralized ad hoc or infrastructure based topology, fixed network topology. Here it is cellular topology or centralized topology. The range is 50 meters and the range is 50 to 100 meters. Quality of service support is statistical, and ATM traffic classes is in Hyperlan 2. So the interface and data rates are conventional LAN, and data rates achieved is 23.5 Mbps. And here we are using the interfaces ATM networks with a data rate of greater than 20 Mbps. So next is a reference model which explains the three handover process. So one is sector handover. So second one is nothing but radio handover, and third one which is nothing but network handover. We are going to see one by one handover process. So MT stands for mobile terminal. So here the mobile terminal is connected and attached with respect to AP. AP stands for access point. AP is access point. Okay, and APT stands for access point terminal or access point transceivers. Access point transceivers or access point terminals. We can either transmit or receive, that is transceivers. And then APC. APC stands for access point controller. Access point controller. So this mobile terminals are connected with an access point to the core network. So MT1 is in the region of 1, and it is connected with respect to access point terminal of the first AP. Whereas MT3 and MT4, these two mobile terminals are connected with respect to second access point. This is a different set of access point and different APTs, different access point transceivers. So the sector handover, by the name itself we can use the sector antennas which is used for an access point. Here access point shall support the sector handover. Here this kind of handover is handled inside the DLC layer, so it is not visible outside the AP. So I'll explain access sector handover. So in this sector handover we are having the handover from MT1. So MT1 to MT2. MT1 is connected with the access point transceiver of the first AP, and MT2 is also connected to the access point transceiver of the first AP. So there exists sector handover. Sector with respect to sector antennas is mobile terminals or receiving the radio frequencies. So next is radio handover. Radio handover, by the name itself we can say that this MT3 moves from one APT to APT of the MT3. This MT3, this is with respect to one APT of an AP, is moving to the this APT, which is of the same APT inside the same access point. So this MT3 and MT4 both are in the same access point. So no problem exists. Because of the radio frequencies, they will be exchanging the information from MT3 to MT4. This is second radio handover. And next is complicated handover, and complexity exists in this network handover when MT2 of first APT of first AP is moving to a different location of MT4. Okay, MT2 is of first APT. APT is the access point transceiver of first AP moving in a different location of an APT of the different access point. This comes under network handover. So network handovers have lot of complexities since it is moving from one region to a different region. So when it is moving from one region to different region, the mobile terminal must provide the required information which is similar with respect to the association, new association, which is in the previous radio handover, right? So next is, so these things we have seen. So radio handover is useful for encryption, authentication and connection parameters. Network handover, it can support both inter and intra, right? So but a sector handover supports only inter. Radio handover supports inter as well as intra AP, APT and AP. So this is the two modes of Hyperlan 2. One is centralized mode, another one is direct mode. So AP stands for access point, we all know. CC is the central controller. MT is the mobile terminal. So here we have an access point that all access points are connected to a core network. This access point will be connected to the core network. And the mobile terminals MT1 and MT2 associated with the AP. This is associated with the AP. This can, even if two MTs, even if the two MTs MT1, MT2 can with the same cell can share the single access point. Data is transferred with a single access point, even they are having two mobile terminals, two different mobile terminals. So here the access point has a complete control over the mobile terminal access. Next is that is the centralized. Next is direct mode. In direct mode, first diagram, this diagram is nothing but shows the direct infrastructure. Second diagram, this is the diagram which is for ad hoc mode. This is for fixed networks with having infrastructure. This is for the ad hoc networks, which is an infrastructureless network. So here the access point is with a central controller. With a central controller is coordinating with respect to same like centralized. But here it has a main mobile terminal which is connected with respect to a central controller. Both mobile terminal without an access point, this is controlled since it is in ad hoc nature. So next is Hyperlan protocol stack 2. Here you have lowermost layer which is the physical layer, and here it is a medium access layer, control layer. Here the radio link layer, error layer, higher layers, right? So here physical layer. So the physical layer which is important to establish communication. So the physical layer will be coordinating which is the lowermost layer which handles the modulations, forward error correction, signal detection and synchronization. So all these things will be performed in the physical layer. Then next comes the data link layer. So data link layer, you have DLC layer. DLC layer, along with the DLC layer with the MAC layer, you have a MAC medium access control, RLC radio link control, sublayer and error control. This RLC and error control. So this RLC will be connected with the access point. So each access point will have several access point transceivers. One access point will have several APTs. Example APT1, APT2, APT3, etc. It may have several access point transceivers. So each access point transceivers has own MAC, own MAC instance. So the MAC is divided into two parts. One is control part and user part. This is the control part. You have radio link control, association control and DLC control. And next part is the user part, right? In user part, it contains a error control mechanisms. Error control is flow control and error control. So reliable data transmissions and acknowledgement and retransmissions will be taken place with respect to the error control. So which is with respect to the user part. Next is radio link control, which is with respect to the control part. Here in radio resource control, it will have a radio link control which controls the whole radio link layer, that is a DLC layer. So association function which will control the association and authentication. Authentication is with respect to the intended receiver, and DLC is not. DLC here it was used for setup, modification and release. Setting up of the connection, modifying connection and release when it is terminating. And radio resource control RRC, which controls the handover between AP, within AP and outside the AP, that is between APs and within AP. Next is the convergence. Here you have DLC control SAP and DLC user SAP with respect to the higher layers. Next is the physical layer reference configuration. So here the data's protocol data unit PDU will be taken as a train. Protocol data unit will be taken as a train from the DLC, that is data link control layer. So data link control layer. So from the data link control layer, the data will be taken as a scrambling. First part is a scrambling part. So in the scrambling part, all the data bits will be having a generated polynomial of, for instance, x power 7 plus x power 4 plus 1. So this will be the generated polynomial. With respect to the generated polynomial, it is responsible for the blocking all the DC components and whitening of the spectrum. So after this, the signal is passed to the forward error correction. So for the forward error correction, it will control the error and protect free from error. That is protecting error protection. Next is interleaving. So interleaving is a process where we do the required frequency to be selected. So how the required frequency is selected? So the required frequency is selected by means of taking the transmission channel with memory which is converted to memoryless. So taking a transmission channel with memory and without memory. So converting from with memory to without memory. So that is the interleaving. So with respect to this interleaving, what happens is that you can if there is presence of any error, that is burst error from the forward error control, what happens is pass through the interleaving. The interleaving improves the burst error by making the burst error to be controlled with respect to codes. So burst error will be controlled with respect to codes in the interleaving stage. And after the interleaving stage, it is passed through the mapping process. The mapping process is having group 1, group 2, group 4 and group 6 depending on the modulation scheme. For group 1, it is using BPSK scheme, and for group 2, it is using QPSK scheme, and group 4, it is using 16 quadrature amplitude modulation scheme, and for the 6 bits, it is group 6, it is using 64-bit quadrature amplitude modulation. So after this bit sequences, it is passed through the OFDM. OFDM is the orthogonal frequency division multiplexing. This converts the symbols into a baseband signal with the help of inverse fast Fourier transform, right? So the inverse fast Fourier transform converts the data bits into the original physical layer data bits where we got from here. So now we have the physical layer data bits. So the data bits are nothing but basic information in zeros and ones, which will be transmitted with respect to the radio transmitter. So in the physical layer data physical burst, it will have the burst signal which contains the information preamble with the payload, and the radio transmission, it will be transmitted the baseband signal to the carrier frequency depending on the channel number. So these are the operating channels of Hiperlan 2 in Europe. Here to calculate the center frequency, which is the frequencies operating here are 5000 range. So 5000 plus 5 into the channel number, which channel number it is used, right? So this is the process of calculating the center frequency. So next is the basic structure of Hiperlan 2. So basic structure of Hiperlan 2 consists of MAC frames, each of 2 milliseconds, right? So each MAC frame consists of the following frames. First is broadcast phase, second one downlink phase, third one uplink phase, and fourth one random phase. What is broadcast phase? So in broadcast phase, all the access point of the cell which is broadcasted, which will have the information that is need to identify the channel, status and resources. Channel, status and resources. Next, downlink frame. So in the downlink, we can transmit transmission of user data from access point to mobile terminal. When we are transmitting the user data from access point to mobile terminal, downlink phase is used. When we are transmitting the data, user data from mobile terminal to access point, uplink phase is used. Then last one is a random phase. Random access phase. This uses the capacity which is request from already registered empties. Already registered empties and access from non-registered empties. Non-registered empties in sense we can say that slotted aloha scheme, which we have learnt in the communication networks. So this is the frame format of the frame, which is LCH. LCH is nothing but long transport channel. SCH is a short transport channel. RCH is the random channel. ACH is the access feedback channel. FCH is the frame channel. So these are responsible for having the transfer of information with respect to payload, and CRC stands for cyclic redundancy check. So with this, our Hyperlan 2 is over. Thank you for your patient listening. If you have not subscribed my channel, kindly subscribe my channel for future videos. Thank you.